Okay, in today's lesson, we're going to talk about electricity. We're not doing magnetism today, we're doing magnetism tomorrow, inshallah, as per the schedule. What we're going to talk about today, Unit 4, would be about, where's my laser pointer first? There you go. We're first going to talk about static electricity, what's an electric charge, positive and negative attraction, repulsion, the usual bananas. How do we charge an insulator? That's by rubbing, if you've heard before. This next bit is not for year 9s, but it's a very short part. How do you charge a conductor? By a method called induction. And what is an electric field? This is very similar to what's a magnetic field. Then we'll talk about what electric circuits are. The story of the circuit, what's a charge, how does it deliver energy, and so on and so forth. We'll then talk about resistors and different types of resistors, what does series and parallel mean, potential divider circuits, and so on. We'll then talk about logic gates, mains, electricity, and safety first, and finally logic gates. This logic gate section is not for year 9 either, so I'll let you know when we get to it. Don't worry, you'll find the usual sign denoting if it's for year 9 or not. Anyway, let's get started. First things first, electric charge. What is an electric charge? It's a property of matter that experiences a force when it's next to other charges or in an electric field. بس ده معناه ايه? If you remember, the structure of any atom includes a nucleus, and inside the nucleus there are protons and neutrons, and outside there are electrons. So we say that protons and neutrons and electrons have a property called an electric charge. We say that protons are positively charged, electrons are negatively charged, and neutrons are neutral. They have no charge, if you remember from what we talked about in atomic physics. But what is charge? Look, there are two properties that all substances and all particles must have. All objects must have mass, as in, they have a certain amount of mass in kilograms, and they must have something called a charge. This charge could either be positive or negative or both. Why is this important? Because charges are one of these natural forces that exist in life, like gravity and such, that naturally attract or repel other charges. So if you have charges next to each other, like if you have a positive charge and a positive charge next to each other, they apply a force on each other. They repel each other. If you have a negative and a negative charge, they also repel each other. And if you have a positive and a negative charge, they attract each other. So charges naturally attract, and this is important when it comes to atoms because the only reason electrons stay inside the orbit and they're bonding with the nucleus is due to the attraction between the protons and the electrons. So just to let you know how important electric forces are and what electric charges are. Okay, so as we can see here, like charges repel, opposite charges attract. That's the general rule. But we're going to add just one rule to charges over here, and that's neutrons or neutral objects. If you have a neutral object next to a positively charged object, they will attract. Let me erase that. I meant to draw it the other way around. So as you're saying, if you have a neutral object next to a positive object, they will attract. If you have a neutral object next to a negative object, they'll also attract. But the question is why? Inside a neutral object, as I said, there are both positive and negative charges. So when you bring a positively charged object close, this negative side is closer, so it gets attracted. Again, inside a neutral object, you have both positive and negative. So when you bring a negative object close, it still attracts. That's the reason why neutral attracts, because it has both negative and positive charges. Okay, good. So that's some basic charge discussion. Let's move on to what an electric field is. And this is a very short point, but this is not for year 9 students, okay? So year 10 students focus, year 9, this will at most take a minute. What is an electric field? It's defined as a region where charges experience a force. Again, it's a space or a region where charges experience a force. If you have a positively charged object and I get a positive charge over here, it'll experience a force and it'll be repelled. It'll be pushed away. But if the positive particle is way out here, nothing happens to it. It just stays put because it's outside of what we call the electric field of the positive charge. فالفيلد is nothing more than a space، مكان كده، حتة كده واسعة هنا، الشارج دي البوزيتيف تشارج object دي بتعمل الفورس بتاعتها. Now here's the thing, how do we draw a field? We draw a field using straight lines coming out of a positive object, as you can see here, or straight lines going into a negative object. And that's because this direction of the field shows you the direction of the force acting on a positively charged particle. تاني, the direction of the field shows you the direction of the force on a positively charged object or particle. So if I have a positively charged object here, it'll move to the left, down here, it goes down, up here, it goes up. So that's what it is. If you have a positive object here, next to this negatively charged sphere, it'll be attracted. If it's over here, it'll still be attracted. If it's over here, it'll still be attracted. So what would happen if you change the charge? And what if I have a negatively charged particle here? It'll get repelled. Same thing. If you put a negatively charged object here, it'll get attracted. So the basic rule of thumb is this: negative charges always move opposite to the field. So negative is always opposite to the field. Whereas positive charges are always in the same direction of the field. So let's just write this here, in direction of the field. Now, a second important point when it comes to fields is that the fact that the drawing that we've just drawn, the field that we've drawn, the shape of it, represents how strong the field is. If the field lines are close to each other, like in this space over here, this means the field is very strong. The repulsive or attractive force is going to be extremely strong. Whereas if the field lines are far away from each other, the field is going to be very weak. Okay, that's all there is to it. So close to the object, field is strong. Far away from the object, field is weak. If you put two different objects in front of each other, not just separate objects over here, like only positive and only negative, if you put a positive and negative charge in front of each other, their fields combine, creating this combined field over here, just hybrid field, moving from positive to negative. As you can see, in this space over here, the field is very strong because the lines are close. In this space over here, the field is very weak. And in this space over here, the field is very strong again because the lines are super close. However, if you have two flat or parallel plates in front of each other, the field takes a different shape. All the lines become parallel to each other as well, and the space between the lines becomes equal. This means that this field has a constant strength all over. So we call this a uniform field. So again, a field is nothing more than a space where charges experience a force. If I put a positive charge over here, it moves in the direction of the field. If I put a negative charge in the same space, it moves opposite to the direction of the field. Plus the attraction and repulsion kind of makes sense on its own. Okay, let's go back to insulators and conductors. We have two different types of materials, insulators and conductors when it comes to electricity. Insulators are materials that do not conduct electricity because they don't have free-moving electrons. Remember, we talked about this yesterday in thermal physics. Whereas conductors can conduct electricity because they have free-moving electrons. We kind of need these electrons because they're free-moving and they're charged, so they deliver electricity. But before we talk about delivering electricity and anything else, we want to talk about how do we make something charged. يعني في examples اللي فاتت, I just said, hey, we have a positively charged object and a negatively charged object, a positively charged object and a positively charged object, and they repel or they attract and so on. But how do we make something positive or negative? As a general rule, you can make something charged, and you can charge any object, I don't care what it is, insulator or conductor, by either adding or removing electrons. دي حتة chemistry شوية, it's kind of like chemistry, but the idea is still the same. If you remove electrons from an object, it becomes positively charged. If you add electrons to something, it becomes negatively charged. And when it comes to insulators, things like plastic or wood or wool or anything else of the sort, you can charge this by rubbing. If you get something like a wool cloth and a glass rod, two different insulators, and this part's important, they have to be different materials. So if you have these two different materials and you start to rub them against each other, like cause a lot of friction between them, this friction forces one of these objects to lose electrons from its orbit. Let's say the cloth is losing electrons, and the rod gains these electrons. So again, the cloth loses electrons and the rod gains electrons. So if I were to draw these separated after we rub them, so if we have our glass rod over here and we have our cloth on this side, because the rod gains electrons, it becomes negatively charged. And because the cloth lost electrons, it becomes positively charged with equal amounts, because the number of electrons lost by the cloth is equal to the number of electrons gained by the rod. Now, this is not always the rule. Now, here's the thing. مش عشان أنا قلت cloth gives the rod electrons means that كل مرة الcloth هيدي للrod electrons. No, it depends on the materials. If we use plastic, if we use cotton, if we use any other type of insulator, it really doesn't matter. Different insulators behave differently. So some of them lose electrons, some of them gain electrons. It doesn't matter. What's important is this. If you rub two insulators against each other, one of them loses electrons, one of them gains electrons, and one becomes negative and the other becomes positive. Capiche? Easy enough. It's a very minor point. Let's move on to the last static electricity point. This is again not for year 9s, because in year 9 we didn't talk about how we can charge a conductor. Conductors already have free moving electrons. So how do we charge something that already has free moving electrons? Again, you make it either lose or gain these electrons. And this is quite simple. In front of you, there's a metal ball. So let's just write that down. Metal ball. And this metal ball, oops, I forgot the L. And this metal ball has positive and negative charges inside it because, it's a neutral object. So let's say it has 4 positives and 4 negatives inside. If you were to bring a negatively charged rod close to the ball, this will change the distribution of the charges inside the ball. هيغير توزيعة الcharges جوا. هيخلي البوزيتيف يتحرك obviously to the left because it gets attracted, and the negative moves to the right. So let's draw this minor change over here. Let's say this side becomes positive and this side becomes negative. Easy enough. If we take a look at the ball right now, it is still neutral because you have 4 positives and 4 negatives, so they're equal. In order to force the ball to become charged, you need to make it lose these electrons or make them gain more electrons. But in this case, we're losing because it's going to lose it because the rod is repelling electrons. What we're going to do now is we're going to connect this metal ball with a wire, just a metal wire. We call this technique the earth or the ground wire, or grounding. Basically, all that we'd say is that we're connecting it to another conductor that has a lot of free moving electrons. So when you touch it to the earth or the ground, basically with another piece of metal or something, these electrons that were currently stuck inside the metal ball, these electrons that are stuck inside the metal ball and are being repelled by the rod, have a way out. يقدروا يخرجوا دلوقتي. So what do? They leave. مش عشان هم عايزين يمشوا, but because they're busy being repelled, they're being pushed away. So these electrons start to leave. Pop, 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 and out they go. Oops, I drew one too many, but that's not important. So when they leave the ball is now positively charged. The ball is now positively charged. Now, if I don't do anything else, and I just keep holding the rod like this and the earth wire like that forever, sure, it's positive. But if you remove the rod, these electrons can come back. يعني لو شلت الرod دي وبعدتها مفيش حاجة عاملة repulsion, so they come back. what I need to do is I need to take this rod and move it far away. Just give me a second, and move it super far away from the ball. If I do that, these electrons come back. خدوا بالكم, if I do that, these electrons have nothing repelling them, so the ball pulls them back. Before I remove the rod, what I actually need to do, I'm just gonna stop writing rod. I'm pretty sure you know what I'm drawing. While the rod is still there, you need to remove the earth wire first. And you need to remove this first. When you remove the earth wire, there's no way for the electrons that have escaped to come back. So after you remove the earth wire, you remove the rod, and now the ball is positively charged. You're left with a positively charged ball. So again, what's the sequence of steps here? Number 1, you bring the rod close to the ball. Number 2, you connect the ball with a wire. Number 3, you remove the wire first. And number 4, you remove the rod, move it super far away from the ball. And with this, the ball has now become positively charged. Excellent. Okay, before I move on to electric circuits, I'm taking a look at the chat for questions. Positive مش بيتحرك. Yes, positive مش بيتحرك. So, okay, let me move back. Mister, how do you make the rod positively charged? Here's the thing. We're assuming that you already got a positively charged rod from somewhere else. And either by charging it with a battery or something, or by rubbing it. بس مهم you got already a positively charged rod. هو مش المفروض البوزيتيف تشارجز ما بتتحركش؟ يس البوزيتيف تشارجز مش بتتحرك، عشان كده ما قلناش ان البوزيتيف بيخرج بره الواير او الاوبجكت. We said you lose the electrons, you don't gain protons. بس اللي احنا رسمناه ده مش ان البوزيتيف اتحرك شمال ويمين، اللي حصل ان الديستريبيوشن بتاع الشارج اتغير، ان the left side becomes more positively charged علشان ال right side بقى more negatively charged. When is it year 9? This is for both year 9 and 10 يا مريم يا تامر. It's just this particular slide اللي year 10 بس. فمتقلقيش, we'll move on دلوقتي. مستر خط حضرتك وحش قوي. I know, right? This thing, my handwriting using this particular setup is really bad, so I apologize for that. It's very hard drawing on a drawing tablet when you don't know how to use it. Okay. Do two neutrons attract? No, two neutrons do not attract. Two neutrons do not attract. They do nothing to each other. ايوه safe. بص again guys اللي لسه داخلين او اتأخروا لما اقوم, we only took a couple of slides here, or just 4 basically instead of a couple. بدأنا بالelectric charge. ايه هي positive and negative. We talked about something called the electric field. This is not for year 9. And then we talked about charging insulators by rubbing, which is normal. And finally charging conductors, which is not for year 9. Okay. This next bit is going to be completely bad for everybody, فركزوا معايا برضه. بس before I do, okay. I'm putting some people in timeout because they're spamming the chat a bit too much. So sorry for this minor delay. Okay. This is electricity, يا جماعة. We talked about this before, and you have the schedule. Today is electricity, and it says so in the title, I swear. Okay. Okay, so I missed the little direction, positive and negative. Omar, this is a choice. This is a choice. And that was decided on by the guys who discovered electricity. So they're the ones who decided to draw the field from positive to negative. ده باختيارهم هم. So we just have to follow through. And it's also the direction of the movement of a positive charge. واشمعنى? Because again, they're the one who's chosen. Jumana, please ask away. Everybody who have questions, again, if you have questions, make sure to write them in capital letters so that I can immediately see them when I look through the chat. Okay? Excellent. A minor warning, everybody who's in current timeout, if you consistently become a disturbance, I'm going to have to, unfortunately, block you from the chat. Okay, let's continue our lesson. This is where it all gets started. This part's really important. But what's an electric circuit? An electric circuit is just a connection of, components, things like a battery, a lamp, a switch. And the purpose of the circuit is to deliver electrical energy. Because remember, the battery has energy. And the purpose is to deliver electrical energy from the battery to the light bulb so that the light bulb can light up. Remember, that's what we want. Okay, good. Now, how does that happen? How does that work? Short story. First, as soon as you close the switch, and remember, when we say the word closed, we actually mean that the circuit is now on. And when we say we open the switch, we actually mean off. Okay? So as soon as I close the switch, charges from the positive side of the battery, we have a charge coming in from the positive side of the battery. It is also positively charged. Leaves the battery carrying with it some electrical energy. Remember, it has energy with it. That's the point. Now, this charge, because it's positively charged, is being repelled by the battery and it moves. Remember, it wants to deliver the energy and it moves through the circuit. And this is why it has to be a closed circuit, because the charge is going to go through the entire circuit and then back to the battery again. So if there's any part of the circuit that's open, like if the wire is cut or the switch is off, this won't work. So you have a positive charge leaving the battery, carrying electrical energy. And then it moves. Happily moving just through the electrical wires with really good conductors, usually made of copper. And then it reaches its first problem, let's just say. The problem is the lamp. But I want the lamp to work. Sure, you want the lamp to work. انت مش مهم. المهم charge. The charge is currently carrying a energy. It's currently carrying energy. It didn't really need it for anything just yet because the conducting wires were really good. وكانت السكة حلوة ورقيقة وفاضية وبتمشى براحته. But as soon as it reached the lamp tries to stop the charge. It resists the charge. So in order for the charge to go through that resistance, and in order for it to go through lamp al-afia, unfortunately it has to give up something. It has to give up the energy that it's carrying. So it gives the energy to the lamp, because the lamp baltagi, and it leaves the other side still a charge, because remember, it's still a particle, it still has mass and charge, but unfortunately it has no energy. It gave the energy to the lamp. Now that's what we want. خد بالك احنا اشرار, احنا عايزين الشارج to lose lamp, to lose energy للlamp. So now the lamp lights up. Yay. طب هتلايت up شوية وتقفل؟ أكيد لأ. We still have to continue to deliver energy to it. فالcharge دي بترجع تاني, being attracted by the battery. بترجع فاضية and it has to go back empty. The battery will not accept the charge لو هي فيها أي energy. The charge goes back to the battery, empty-handed. The battery gives it some more energy, and the cycle repeats itself. So again, as soon as you close the switch, بيطلع charge شايلة energy from the battery. هنسمي دي بعد شوية voltage. The charges now move. This motion of charge is called a current. So the charges now move, and as it moves, يوصل للlamp. The lamp tries to stop it because it's an annoying piece of teeth. I had to mute myself, haha. Sorry. The lamp stops the charge. I amuse myself very easily. The lamp stops the charge, and the charge has to deliver energy to the lamp. And it loses its energy to the lamp, and it leaves the other side without energy, but still a charge, and then it goes back. بس كده. And that's the story of an electric circuit. And this will help us understand what's the difference between the three electrical quantities we'll study in a bit, called voltage, current, and resistance. Now, one more thing though, قبل ما أدخل على quantities, we're not going to be drawing circuits the way I've illustrated before. Oh my god, stop. Wow. I'm not going to be drawing charges the way I've drawn before, or circuits, I'm sorry. We're simply going to be using symbols. So if I'm going to redraw the exact same circuit as before, it's going to be a battery. This is a symbol for a battery. This longer line represents the positive side. This shorter line represents the negative side. And then I'm going to draw a switch. The switch is always drawn like an open line. Okay, it always is drawn open. I don't care if it's realistically closed or open. It's always drawn open. And then the light bulb. There we go. That's how you draw an electric circuit. We have so many other symbols that we need to memorize, but we'll use them or just go through them later. You'll find the list of these symbols at the back of your notes. Okay. Next. The three quantities that we need to discuss in electricity are voltage, current, and resistance. Then voltage, current, and resistance. The equations, there's a small mistake with the slides here. Just give me a moment. Phew. Let's keep the annotations. This goes away. Bam. And let's there we go. Let's continue. So as I was saying, voltage, current, and resistance. We have three quantities that we're going to be studying when it comes to electricity. We've already mentioned them before. The first is called voltage. It's defined as the energy per unit charge. What do I mean by that? And it's measured in voltage. If you go back to the diagram, when the battery gave energy to the charge, that is just called voltage. The energy that's carried by the charge is called voltage. Now, the reason we call it energy per charge is because what if I have two charges? You know, each one still carries a little bit of energy. So if the lamp or the battery is a 10-volt battery, this means that this carries 10 joules. So we call it the 10-volt battery or charge. In this case, this is also 10 volts. It also carries 10 joules. If I have three charges, this one also carries 10. So 10 volts is not the total energy in the battery. No. It's the amount of energy per each charge. كل واحد هيديليفر كل تشارجايه واحده كده غلبانه شايله قد ايه؟ مش التوتال، اوكي؟ يعني كل charge هتديليفر قد ايه eventually يعني. It's measured in a unit called voltage. Now there are two names when it comes to two different definitions when it comes to voltage. The first is called the potential difference and the other is called the electromotive force, PD و EMF. They both mean voltage. Again, they both mean voltage. However, potential difference is the voltage across anything like a lamp or a resistor, as we'll see in a bit, or any other component that wants to take energy away from the charge. It needs energy to work. Electromotive force also means voltage, but it's the voltage of things like a battery or a power supply, زي الفيشة. So they both mean voltage. So if you see the term potential difference or electromotive force, they both mean energy per charge. But potential difference means energy lost by the charge when it's going through a component. And the electromotive force is the energy gained by the charge when it goes through the battery, because the battery gives energy to the charges. Okay, that's easy enough. What about current? If we go back, these charges that now carry energy, voltage, are moving, and they move at a certain speed. Sometimes they move super quickly, and sometimes they move very slowly. The rate at which they move, من الآخر يعني how fast they're moving and how many charges are moving, is called the current. Current is simply defined as the rate of flow of charges. How many charges flow through the circuit per second. That's pretty much it. The unit of measurement is called ampere. So if I were to go back to this diagram again, and let's say, we already drew three charges over here, so let's say the current in this circuit is 3 ampere. This means there are 3 charges going through the circuit every second. Okay, so 3 ampere. If I say 1 ampere, that's 1 charge per second. 2 ampere, that's 2 charges per second. If I say something like half an ampere, it doesn't really mean I've broken the charge in half, although you could think of it that way. But it simply means that the charges are moving very, very slowly. The current is very low, moving very slowly. So you're delivering energy much slower. And finally, the last quantity is called resistance. Just a moment. Something crashed a bit, I think. There we go. Yeah, it couldn't handle all my, moving around super quickly. That's what happens when the current increases again. It overloads. Haha. Anyway, as I was saying, resistance is a property of matter that resists the flow of charge. It's something inherent in all conductors. كل الconductors, الwires, الlight bulbs, حتى الباتري على فكرة يعني ليها حاجة اسمها resistance. It tries to stop the charges from moving. وده الفرق ما بين a good conductor and a bad conductor. A good conductor has very low resistance. مش عايز يوقف التشارج. طبيعته انه بيمشي التشارجز بسرعة. Maybe it has a lot of free moving electrons. Maybe spaces ما بين الatoms كبيرة. That's not important. What's important is that it is not trying to stop the charges. So we say it has low resistance. The wires are an example of things that have low resistance, or the copper is something that has low resistance. Okay. Give me a moment يا جماعة ثانية. The lamp is something that has very high resistance. The lamp is something that has a very high resistance. And this is important for us because we don't want the chargers to just pass through the lamp وتنفض لها وما تديهاش energy. So because the lamp has resistance, it slows the current down and it takes energy away from the charges because it's trying to resist. So resistance is a property that's very important. Basically, because there is resistance, the current decreases a bit, but it's also the reason why components can take energy from the charges. So if the resistance increases, the current decreases. If the resistance decreases, the current increases. Excellent. I'm just going to go through the chat بقى دلوقتي just to see if there are any questions. If you just draw a single line, like a single long and short line, which is the symbol for a cell, تعالى أوريكم بس السيمبل ده شكله عامل إزاي. Circuit diagrams. Like instead of just drawing the long battery, you can just draw a cell, which is just a long line, a short line, and that's fine. This is what we call a cell, and the other is called a battery. But if you change between the two, it doesn't really matter. مش هينقصنا if we draw one of the two, unless السؤال literally عايز, and that's super specific, إنك ترسم الباتري مرة أو السل مرة. Another general symbol that works is this. This is the symbol for any supply. Be it بقى DC supply زي السيل أو الباتري أو an AC supply زي الفيشة. He also accepts this. Okay. Won't the charge become neutral when they give away their energy? لا يا جمانة. جمانة, he does not give the charges do not give the lamp their charge. The charges give them energy. Charges are charges. They are either positive or negative. They're either protons or electrons. They cannot lose that positive or negative charge because هم كبارتكل خلاص هم طول عمرهم هيفضلوا يا positive يا negative. But the charges can carry energy with them. يعني يقدروا يشيلوا معاهم energy. يعني يبقى شايل في ايده شوية energy ويوصلها. تمام؟ بس. So when it delivers energy. It does not deliver its own charge. Here, the only reason it's important إن هما يبقوا charge is because they kind of need to carry energy with them and deliver it. وعشان يحصل لهم attraction و repulsion. هما ده السبب إن أصلا هما دول بيحركوا السيركت ويوصلوا الانرجي. بس. Okay. هي مش الباتري chemical energy. Yes, هنا. A battery has chemical energy, but as it gives that energy to the charges, it becomes electrical energy. Okay. Any more questions? نرجع بس تحت تاني بقى كده. هو الفولتج بيتقال عليه potential difference. Yes. Can the charge become neutral after the we've already answered that. مش فاهم how resistance works؟ حاضر يا مروان. And does 0.5 ampere deliver؟ لا 0.5 ampere means there are 0.5 charges moving per second. That's all. مش معناها ان هو بيديليفر half a volt per second. الفولتج اللي هتوصل هي الفولتج اللي مكتوبة. If it's 10 volts in this diagram يبقى it's 10 volts being delivered. Okay? But when I say 0.5 amps, that means that there's 0.5 charges moving per second. That's basically their speed. للناس اللي بتسأل what is Q اللي في equations اللي احنا كاتبينها دي للشباب بتوع الأو level. Q is short for charge. They're basically definitions. ثانية واحدة. Voltage is how much energy per charge. How much energy per charge. And current is how many charges per second. بس كده. Okay. Excellent. Let me just recap حتة potential difference و EMF الأول وبعد كده هعيد تاني resistance because these were the two questions. Potential difference and EMF both mean voltage يا جماعة. They both mean voltage as in how much energy per charge. Let's clean this up first. So how much energy per charge? They both mean voltage. بس كلمة potential difference is used when we want to talk about the voltage across the lamp. يعني لما هاجي أقول what's the voltage across the lamp? We usually don't say that. We say what's the potential difference across the lamp? But we mean voltage. When we want to talk about the battery, we use electromotive force. So if I go back to the circuit and I say what's the voltage across the battery? We don't say that. We say what's the potential, what's the EMF of the battery? As in how much energy does the battery give us per charge? They both mean voltage. And if you say voltage, that's absolutely fine. ومفيش فرق خالص. We're just stating them so that one, you'd know the difference, and two, he likes to use the terms potential difference and EMF, not the term voltage a lot. Because there is a difference. The charges, as they go through the lamp, lose energy. The charges, as they go through the lamp, lose their energy. The charges, as they go through the battery, gain energy. فاضطرينا نديها اسمين because مرة you're losing volts and مرة you're gaining volts. فاديناهم two different names, but in the end they're still called volts. Okay. Next, resistance. What is resistance? As I said, it's a property of any conductor that tries to slow down the charges. Think of it this way. Realistically speaking, الcharges اللي ماشية جوه any conductor, let's just say this rectangle is our conductor, الناحية دي positive و negative, فالcharges عايزة تمشي كده through that space. When the charges are moving, our electrons are moving, or whatever is moving, realistically الدنيا جوه مش فاضية. هو أكيد لسه في إيه؟ atoms وحاجات تانية في السكة, sometimes a lot, sometimes a few. والfree moving electrons بتساعد الconduction إنه يحصل. So depending on the material, it's sometimes hard to go through. It's very difficult. إن أنا أقعد أمشي وأخبط في ده وأطلع وأعمل وألف وتشارج تمشي. So it has to slow down and it loses energy. ده اللي بنسميه resistance. وكل ما بتزيد كل ما الكرنت بيبقى أبطأ. يعني it has to slow down more and it has to swivel more. بيتخبط أكتر and it takes a long time for it to get out. If a substance has low resistance, يعني الدنيا جوه رايقة, تيجي البوزيتيف تشارج دي تمشي, what can it do? Well, it just goes through. فبنقول دي عندها a low resistance, so بتمشي current بسرعة. يعني charges بقى كتير ممكن تمشي في نفس الوقت ويمشي بسرعة. This just depends on the material, and the only material we need to know of is copper, because copper is the best conductor because it has very, 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 very low resistance compared to all the other metals had. Excellent. A final point I want to add. The current, that rate of flow of direction, has a direction. The direction of the current is always from positive to negative. If I ask you what's the direction of the current, it's always from positive to negative. But this is what we call the conventional current. This is what we call the conventional current. The direction بتاع current طبيعي اللي احنا اتفقنا عليه. Realistically, however, الparticles اللي actually بتتحرك في circuit, the particles that actually move in the circuit, are the electrons. And because the electrons are negative, they actually move from negative to positive. The real particles that move are electrons. We call this the electron flow. طب هتيجي تسألني سؤال، لما أنا أرسم الدايركشن بتاع الكرنت، أو لو جه طلب مني الدايركشن بتاع الكرنت فين، هيبقى إيه؟ هيبقى من negative لإيه؟ لpositive. Direction of the current will be from negative to A to positive. Excellent. ده لو ال direction بتاع الإلكترون sorry. ال actual current اللي احنا نستخدمه طول عمرنا من positive to negative. So current is from positive to negative. لو سأل على electrons هنقول from negative to positive. I'm going to take a look at the questions now and go through the chat because apparently we have people being annoying. Okay, guys, I apologize. واحدة. Okay. Okay, next. Okay. ما فهمتش last part. Which part يا هاجر? Just clarify because I just repeated everything. So, Omar, what is Q? I just answered that. It's the charge. To escape من a circuit. Actually لا. ما ينفعش ال charges to escape من ال circuit. The circuit has to be closed ولازم الحاجة تمشي ايه جوه ال circuit. Okay. What will happen if there is no positive charge? لا بص خد بالك يا علي. We just say إن positive charge هو اللي بيمشي and that's all. احنا بس بنقول positive charge اللي بيمشي. ما فيش حاجة اسمها what if there is no positive charge and no negative charge. لازم أي circuit يبقى فيها ناحية positive وناحية negative عشان تشتغل. Otherwise there won't be a circuit. So how do we بقى measure voltage on current? Because we can't really measure resistance. Actually we can. في device بتقيس resistance اسمها ohm meter. We use it to measure resistance. But we don't really use it very much. Instead, we measure voltage and current using devices called voltmeters and ammeters, and we calculate the resistance. بس عشان calculate them, we'll see in a bit the equation. But for now, to measure the voltage, we need a device called a voltmeter. The voltmeter is a component, the device, that is always connected in parallel to whatever point in the circuit you want. It's always connected in parallel to the point in the circuit that you want. If you want to connect an ammeter, it has to be connected in series to the circuit. So it has to be placed somewhere in series. And it doesn't matter if you place it here or here. The symbol ده اللي فيه A ده الاميتر. والsymbol ده اللي جواه V ده الايه؟ voltmeter. بس كده. So الاميتر لازم يتحط في الواير نفسها عشان يقيس الكرنت اللي بيتحرك. الفولتميتر لازم يتحط parallel عشان يشوف الفولتج اللي الكومبوننت بياخده. Parallel to the component. If you connect the voltmeter in parallel to the battery, it will measure the total voltage اللي طالع من الباتري وخلاص. بس. Now, the next law is called Ohm's law, and this is the most important equation we have. It's quite simple. بتقول V equals IR. ماشي? It says V equals IR. Voltage, V is the voltage, equals current times resistance. But so what does this tell us? If you make the current the subject, I equals V over R, okay, it shows you a couple of things. First, بتوريني إن the current والvoltage are directly proportional. يعني أنا لو زودت الvoltage by getting a larger battery or something, الcurrent هيزيد. وطبعا if you decrease the voltage, الcurrent هيقل. This also shows you in the current and resistance are inversely proportional, meaning لو أنا زودت resistance, الكرنت يقل. and this is something we've already mentioned before. بس الراجل اللي اسمه اوم هو خد الثلاثة الحاجات دول مع بعض وعرف يلاقي relationship ما بين الثلاثة. So V equals IR. Now if you want to calculate voltage, that's the equation. If you want to calculate current, هنقول I equals V over R. If you want to calculate resistance, هتقول R equals V over I. Just make sure you're rearranging the equation correctly. There's only one condition for this to work, and that it has to be at a constant temperature. This thing has to be at a constant temperature. Great. علشان ال temperature بيأثر على resistance. لو ال temperature of any conductor ركزوا في اللي بقوله زاد ال resistance بيزيد. لو ال temperature قل ال resistance بيقل. That's pretty much it. فتاني كل ما ال temperature تزيد ال resistance بتزيد. كل ما ال temperature بتقل ال resistance بتقل. So let's use Ohm's law. This is a quick example كده. بيقول لك calculate the potential difference قصده بيها voltage needed to drive an 0.02 ampere current, so that's the current, through a 500 ohm resistor. دي علامة الأوم resistor. So what does he want? He wants me to calculate the voltage. So here we go. V equals I times R. I اللي هي 0.02 times R اللي هي 500. I'll pull out my trusty calculator. Oops, it's way too far. مش عارف ليه حطيتها بعيد قوي كده. 0.02 times 500 equals 10 volts. Equals 10 volts. And that's pretty much it. That's how you use the equation. Now, a couple of things I need you to notice. كان ال current بالأمبير, resistance بالأوم, والvoltage طلع بالفولت. What if I change the current واديتها لك بالملي أمبير? It would look something like this. هيقول لك 20 MA. MA is short for milli ampere. Milli ampere. I can't use this زي ما هي. I have to convert it to ampere عشان أطلع ال answer بالفولت وده بالresistance. فكل اللي هعمله هنقول 20 divide by 1000. ده لو كان مديني بالملي أمبير. هيطلع لي 0.02 أمبير وبعد كده we use it just like we used it here. خلاص ده لو كان if the current was in milliamperes, not if it was in amperes. So you just convert it from milliampere to ampere. And that's Ohm's law. Basically, almost all of the circuits we're going to be using equation basically هنستخدمها طول الوقت هي Ohm's law عشان calculate voltage أو current أو resistance. بس كده. Great. Okay, I'm going to take a final look at the chat before we move on to resistance and resistance wires and series and parallel. And basically بعد series and parallel هتبقى basically كل حاجة constant يعني. Okay, مستر أنا مش فاهم ازاي current directly proportional to voltage. لما voltage بتزيد when you increase the voltage of the battery it pushes harder يعني it gives more energy and it pushes the charges harder so the charges move faster. That's why current voltage لما بيزيد current بيزيد and vice versa. vice versa وفايس فيرسا مش كده يا مستر. ايه ده قصدك ايه؟ فايس فيرسا يعني العكس صحيح. لو الفولتج قل الكرنت هيقل بس. طب لو في الثرمستر لا بقى الثرمستر يا عمر is a special case ودي هناخدها بعد شويه يعني هنراجع عليها تاني بعد شويه بس الثرمستر is a different case. مستر انا السؤال ده اومز لو اليونت تجيبه اوميجا ساين مش كده؟ يس هو ده الساين. لو انتوا مش عارفين تعملوا الساين بتاعت الاوميجا اللي هي العلامه بتاعت الاوم دي just write ohm OHM. اوكي اوكي واو. هو الشات باظ كده ليه النهارده؟ في ايه يا جماعه؟ اوكي let's continue بقى خلاص. when do we use R equals V over I? Again, لو اداني voltage و current وطلب مني calculate the resistance. So it's a quite simple thing. يعني في example ده I gave you the current and the resistance وقلت لكم هاتوا ال voltage. I can easily do the opposite. I could just give you the voltage, give you the current وأقول لكم هاتوا resistance. Yes, Hannah, we answered that question before. We said battery is chemical energy, بس لما بتدي energy للcharges بتحولها من chemical energy to electrical energy. Okay, you're welcome. Okay. يا حد تاني؟ Okay. Okay, let's continue بقى. Now, we finished talking about V equals IR, but there's one thing we need to talk about, the wires themselves. Usually we say that a wire has no resistance, but that's because we're talking about copper here. The connecting wires دي كلها are made out of copper, so they virtually have no resistance. However, regular wires made out of any other materials like iron and steel and anything else, they do have resistance. يعني حتى copper بصراحة it has resistance but very low, but they do have resistance. So the thing is بقى, the resistance of a wire, what does it depend on غير الماتيريال? First, it depends on the length of the wire. كل ما اللينث بتاعت الواير تزيد، يعني كل ما اللينث تزيد. If I have this length and it's 10 ohms, if I get another wire of double the length, if I get a wire of double the length, let's say 20 ohms, double the length, sorry, هتبقى 20 ohms. If you decrease the length, الريزيستنس هتقل. فكل ما اللينث تزيد الريزيستنس بتزيد، كل ما اللينث بتقل الريزيستنس بتقل. So we can simply say that length is directly proportional to resistance. بس. What about the area بقى? If you have a certain wire with a cross-section area, this is the area we're talking about here, of a certain cross-section area A, and it has a resistance of 20 ohms. If I give you a wire that's double the thickness, double the cross-sectional area, الريزيستنس هتقل، هتبقى 10 ohms. This means that لما الاريا بتزيد الريزيستنس بتقل، ولما الاريا بتقل الريزيستنس بتزيد. But a very important question is why؟ يعني ليه في relationship دي؟ يعني ليه لما length بتزيد resistance بتزيد؟ This is kind of simple. لو أنا عندي charge واحدة هتمشي through this resistor, it has to slow down only for this much, this particular distance. But if I have a wire that's longer هيضطر الcharge ده يبطأ for a longer distance. So the longer the resistor, the greater the resistance. This kind of makes sense. حتة بقى area is even better. If this amount of space only allows one charge to go through, let me change the color here a bit so it's a bit clearer. If this allows only one charge to go through at a time, increasing the area allows more charges to go through at the same time جنب بعض. And if more charges go through ده معناه إن الcurrent زاد. ولو الcurrent زاد يعني أنت بتمشي charges أسرع. This means that the resistance has now decreased. You're not resisting as before. Whereas هنا الcurrent قليل فالresistance إيه؟ عالي. Excellent. So we can simply say that area is inversely proportional to resistance and length is directly proportional to resistance. Usually بحب أختصر لما أجي أكتبها لنفسي وبقول resistance is proportional to دي علامة proportional length and inversely proportional to area تتكتب بالطريقة دي. Okay. Next. الإيكويشن اللي جاية دي مش ل year 9 okay عشان year 9 خدوا power اللي هي power equals energy over time في أول السنة بس مش في electricity. In electricity, if you want to calculate power, we don't really use power equals energy over time because the instruments that we have don't measure energy and they don't measure time in a circuit. We do have voltmeters and ammeters though, so we can measure voltage and we can measure current. فبنقول P equals V times I. P equals V times I. بس خدوا بالكم من حاجة. if I want to calculate energy برضو يعني what if I want to calculate energy مش power؟ ما تنسوش إن power equals energy over time as written over here. If I want to calculate energy, make E the subject. فهنقول E equals power times time. However, power في electricity is V times I صح؟ فنقول V times I times T. V times I times T. V اللي هي كام؟ اللي هي مين؟ sorry الvoltage. I اللي هي الايه؟ current و T اللي هي ايه؟ time. So if you want to calculate energy, you could just say VIT في electricity. Okay, where VI represents the power. Okay, good. فpower equals V times I أو I times V في electricity. فيلا بينا example كده سريع بيقول لي an electric fan requires 230 volts and 0.4 amperes to work normally. Calculate the power of the fan when it's working normally. دي أول حاجة أنا عايزكم تحسبوا الباور معايا. And the energy consumed by the fan in 1 minute. يعني أنا عايز حاجتين دلوقتي. I want power and I want energy. ف number one power equals V times I. P اللي هي كام؟ V sorry اللي هي كام؟ 230 times I اللي هي 0.4 هيطلع لي just a second 230 times 0.4 هيطلع لي 92 watts 92 watts. فكده طلع لي power and remember the unit of power is watt زي اللي في unit 1 so it has not changed so far. That's the first part of the question. The second part of the question is he wants the energy. فما ننساش إن energy equals V في I في T. But why write that down when I already have power? فأنا ممكن أقول power times time على طول. يعني ممكن أقول power اللي أنا already جبتها هنا. I'll just plug it into the equation down here. فنقول 92 times التايم هنا 1 minute. ما ينفعش أنا أستخدم التايم بالminutes. It has to be, it must be in seconds. فعلى جنب كده الأول ما ننساش لو سمحت إن 1 minute يعني 60 seconds. فنقول times 60 فهيطلع لي 92 times 60 which is 5,520 joules. تمام؟ طيب. That's if I want to calculate power and that's if I want to calculate energy. They're both just fine. So one last thing هقولها بس في الباور قبل ما نرجع بقى تاني لبقية السيركتس والسيريز وبارallel وكده. There are two other equations if I want to calculate power. ساعتها نقول power equals I squared for R أو ساعتها نقول power equals V squared over R. دول جم من إن إحنا خدنا P equals VI و V equals IR حطيناها في بعض. يعني أنا قلت V equals IR and if I take IR and I plug it into V هيبقى P equals I R I اللي هي I squared for R. So that's one equation. I squared for R is one equation. Or you could say I equals V over R فنشيل V over R ونحطها مكان ال I. Just substitute يعني. نقول P equals V times V over R هيبقى V squared over R. So that's why there are two other equations for power. But my personal preference is this. I don't need to memorize these. لا. لو أنا already حافظ P equal VI وعارف Ohm's law اللي هي V equals IR I can calculate everything I want. اداني power هستخدم VI. اداني resistance هستخدم V equal IR. اداني like current and resistance وقال لي هات power. اوكي برافو. هات current times resistance نجيب الفولتج حط الفولتج وهات الباور. It's only these two equations that we'll be juggling around في year 10. year 9's هو V equal IR بس. يعني ما عندناش أي شيء آخر يعني. Okay, excellent. Next بقى. Components اللي عندنا منهم كتير. It's not just light bulbs. عندنا ساعات resistors and we have 4 different types of resistors that we'll talk about. Something called a fixed resistor. يعني ده component ما بيعملش حاجة في حياته غير إنه يresist بس. It's just resistance. A variable resistor which is a resistor whose value can be changed. ده هيتغير بالlength زي ما هنشوف كمان شوية. A thermistor ده بيتغير مع temperature وال LDR ده بيتغير مع light. So as I just said, the fixed resistor is fixed. If it's 10 ohms, it's 10 ohms. Thanks. شكرا. The variable resistor بقى الديزاين بتاعه مختلف شوية. It's made of a long resistor wire ومتوصل بباتري أو cell. Let's put an ammeter over here عشان نشوف الكرنت هيحصل له إيه. But instead of connecting the entire wire, let's say كلها 10 ohms برضو, we can connect the other side of the ammeter or the rest of the circuit with what we call a sliding contact. Sliding contact. What is a sliding contact? It's just a component that is allowed to move freely على الواير, فبيغير لي point of contact بتاع الواير. For example, الشارج اللي ماشي من هنا من positive side of the battery current وهو طالع هيمشي through the wire. If it goes through the entire wire يبقى دي كده 10 ohms, بس let's say هي وصلت لحد نص الواير بس, يعني it reaches only the halfway length of the wire. ده هيخلي الكرنت يطلع من الواير ويرجع تاني للباتري without going through the full length, يعني كأنه عدى على 5 ohm بس. by changing the length of this sliding contact, المكان اللي هو راكب فيه, I can change the resistance. If I connect it farther away, يعني زودت اللينث شوية, let me redraw this. If the sliding contact is like over here على ammeter والcell and the entire length is over here, ايه اللي بيحصل؟ الريزيستنس هتزيد, هتبقى 10 ohms. ولو السلايدر اتحرك للشمال الريزيستنس بتقل. So that's why it's called a variable resistor, because you can change the value of the resistance by changing the length of the wire freely. A thermistor من اسمه is a resistor that changes with temperature, وده ما بيمشيش مع الرول اللي احنا قلناه من شوية. التمبرتشر لما بتزيد احنا قلنا resistance بتزيد, but that's in a regular conductor. The thermistor, it's not made of a normal conductor, it's made of special materials called semiconductors. When its temperature increases, its resistance decreases, العكس. And if the temperature decreases, its resistance increases. يعني لما بتسخن الريزيستنس بتاعتها بتقل, لما بتسقع الريزيستنس بتاعتها بتزيد. وبتسخن وتسقع simply by putting it somewhere that's either hot or cold. يعني حطيت مثلا الثرمستر جوه كوباية شاي or something, its resistance drops. حطيتها في التلاجة أو في الفريزر, resistance بيزيد. And this is usually what they use when we say that we have a temperature sensor or something inside an AC, an air conditioner طبعا قصدي, أو جوه الفرن بتاعك. Usually بيبقى فيه thermistors that allow us to measure the temperature using change in resistance دي. فالثيرمستر تاني لما temperature تزيد resistance بتقل, temperature بتقل resistance بتزيد. That's the only thing that follows this case for now. regular metals العكس, لما temperature بتزيد resistance بتزيد. As for an LDR, LDR is short for what we call a light dependent resistor. A light dependent resistor. So what is a light dependent resistor? It's a resistor that depends on light. يعني لو اتحط في النور اللايت اللي عليه زاد, الريزيستنس بتاعته بتقل. ولو اللايت اللي عليه قل, يعني حطيته في أوضة ضلمة, الريزيستنس بتاعته بتزيد. So by changing where the LDR is placed, if you place it somewhere bright or somewhere dark, resistance ممكن تقل أو ممكن تزيد. This is what we also call a light sensor. So all three of these, sorry, I marked the fixed resistor full. All three of these are variable. Variable resistor, thermistor, LDR, they're all variable resistors. But the variable resistor changes if you change the length. The thermistor changes if you change the temperature. The LDR changes if you change the light. The fixed resistor is fixed, it's just constant. The function of any variable resistor, or usually any resistance, is to limit or control the current. Because the reason we want to control the current in the circuit is because if we increase the current, مثلا if there's a light bulb connected, it'll light up brighter. If we decrease the current, it'll become dimmer or darker. We often do that by either using thermistors, LDRs, or variable resistors. Okay, taking a quick look at the chat. Okay, Mr. لما التمبرتشر بتزيد الريزيستنس بتقل. Yes, في الثرمستر بس. Only in the thermistor, okay? مش فاهم الريزستور تايب دي. بص يا زياد، هما بس الريزستور ده component بيقلل الكرنت، بس ده هدفه في الحياة. Some of them have fixed values and some of them just change in value، يعني بيزيد بيقل and so on. So واحدة منهم اللي هي الفيكس resistor that's fixed. The other three اللي هم الفاريبل والثيرمستور والLDR دول حاجات ليهم resistance يعني بتقاوم، بس they are not fixed. تاني they are not fixed، بيتغيروا. الفاريبل ريزيستور بيتغير لما بتغير اللينث بتاعت الواير، يعني لما الواير تطول الريزيستنس بتزيد، لما الواير بتقصر الريزيستنس بتقل. الثيرمستور بيتغير مع التمبريتشر، والLDR بيتغير مع اللايت بطريقه inversely proportional، يعني لو التمبريتشر او اللايت زادوا resistance will decrease، لو التمبريتشر او اللايت قلوا resistance will increase. زياد بص V equal IR is nothing more than an equation. هتحط V equals IR، هتسبستيوت الفاليوز في الايكويشن وشكرا. Okay. Great. Okay, next. year 9 لا لسه، انا year 9 لما هخلصهم هقول لكم انتوا خلصتوا امتى، متقلقوش. As for a break, I guess لا فاكس، يعني we don't have much left بالنسبة ل year 9. So خلينا لما نخلص وناخد break عشان year 9 يكونوا مشيوا وكنا ناخد ايه break مع بعضين. Okay. بس كده. So let's continue. بصوا شباب ال year 9 we only have حوار السيريز والparallel و mains electricity في البيت. After we're done خلاص الموضوع انتهى and you can go. بتوع year 10 و 11 we can continue on على طول or we could take a break وقتها يعني. So let's go back to series connections. Now there are two ways in which we connect components in a circuit. We either connect them in series بالمنظر ده اللي احنا شايفينه or we can connect them in parallel اللي هي بالطريقة دي زي ما احنا شايفين. When we connect objects in series, a few things happen. First, التوتال resistance في السيركت بيزيد because كل ما بركب حاجات أكتر كأني بطول wire فthe resistance increases. Second, الكرنت اللي ماشي ده هو current واحد بس، قليل وبيمشي بالراحة because the resistance عالية but it's just one current، وهتعرفوا ليه بقول كده بعد شوية. And finally الفولتج اللي الشارجز شايلها بتتقسم. تعال بقى نشوف اللي بيحصل. Again, if I were to, as I said, connect this to a cell, and let's say, for the sake of مضايقاني بس الخط ده مضايقني. For the sake of clarity, that this is a 10 volt battery, and this is a 10 ohm resistor. This is also a 10 ohm resistor. يلا 10 is everywhere. وعندي current اسمه I هيمشي في الواير. First, التوتال resistance بكام؟ قصدي ايه بتوتال resistance؟ يعني لما ركبتهم الاتنين مع بعض combined ادوني resistance في السيركت بكام؟ التوتال ريزيستنس هنا هتبقى 10 بلس 10 ب 20 ohms. يعني انا لو شلت الاتنين دول وركبت واحدة 20 ohm هيديني نفس الكرنت في السيركت. يعني لو ركبت واحدة 20 ohm هيديني نفس الايه الكرنت في السيركت. طب حلو. نمبر 2 الكرنت بكام؟ well زياد عشان كنت بتسأل على V equal IR here's an application. انا عايز احسب الكرنت اللي هي ال I. remember V equals IR. if I want I make it the subject هيبقى I equals V over R. ال V بكام؟ let me just erase the diagram اللي تحت دي. ال V اللي هي بكام؟ ب 10 because احنا قلنا من شوية 10 volts. خلاص مكتوبة اهي. ال R اللي هي 20 ف 10 over 20 هيديني 0.5 ampere. فاحنا كده جبنا ال current using V equals IR أو I equals V over R عشان جمانة برضو كانت بتسأل. Finally, and number 3 بكام بقى الفولتج اللي على كل component في دول؟ أنا لسه قايل الفولتج بيتقسم ليه بقى؟ every single charge اللي جاية دي دلوقتي let's say شايلة 10 volts زي ما اتفقنا. بس this charge over here اللي داخلة مينفعش تدي 10 volts كلهم to the first resistor because لو ادت الانرجي كلها لاول ريزيستور مش هتعرف يبقى عندها انرجي كفايه تديها لتاني ريزيستور. So it kind of has to split الفولتج اللي معاها. So we calculate this simply by using the same equation. V equals IR. بس let's say I want to calculate what we call V1. فنحط R1 بس. هننقي بقى. ال I ب 0.5 لسه جايبينها من شوية اهي فوق. وال R اللي أنا عايزها اللي هي 10 ohms. أنا مش عايز أحسب على التوتال، أنا اخترت أحسب على دي بس. كأني حطيت فولت ميتر هنا وعايز أقيس الفولتج هنا ايه بس. ف 0.5 times 10 هيطلع لي ب 5 volts. يعني ده هياخد let me change the color over here. ده هياخد 5 volts. وبما ان التوتال فولتج 10 ده برضه هياخد ايه 5 volts. يعني الفولتج اتقسم عليهم، الانرجي اتقسمت عليهم عشان التشارج الواحده الغلبانه دي هتضطر تعدي على 2 في نفس الوقت. اوكي excellent. حد عنده سؤال في السيريز قبل ما اتحرك واكمل البارالل؟ اوكي can you increase the brightness, can you repeat this part. ماشي يا مريم. هو لما الاريا اول ما الدايمتر increase بيحصل ايه الريزيستنس؟ لما الاريا بتزيد الريزيستنس بتقل. they're inversely proportional. why بس لما بيزيد بيقل؟ you did not specify مين بيزيد بيقل. هنا a thermistor is just a resistor that changes with temperature. يعني لو سخنته الريزيستنس بتقل، لو سقعته الريزيستنس بتزيد. it's not fixed. why لما temperature بتزيد resistance بتقل؟ again it's made of a specific material زي ما قلت حاجة اسمها semiconductor. وبصراحة مش هندخل في الديتيلز بتاعت ليه semiconductor اللي بيغير resistance بالطريقة بتاعته دي، يعني خليها مش في وقتها دلوقتي. it's kind of advanced شوية. I هي current yes. السبب ان هم اختاروا كلمة I for current is because I is short for electric current intensity. هم خدوا كلمة I من intensity. I just want to let you know I have a moderator or two on the chat now to help me keep the spam down. If you're spamming and not writing questions, or at least يعني if you're spamming a lot حاجات ملهاش لازمة وعشان الحاجات دي بتظهر على السكرينز بتاعت الناس وبتبوخها يا جماعة. So please be civilized enough to just make sure to ask questions, okay? ماشي يا جميل؟ where do we put the ammeter in the circuit? We always put it in series. يعني in a circuit like this, يعني let's try this out on our circuit. In a circuit like this, I would put the ammeter either here or here or here or here. So let's draw one of them. I don't want to here, and draw one of them. Let's put it over here. بس كده. I can put it here. Or maybe I can put the ammeter here. بس كده. Okay. الثرمستر دي تتحط زي اي ريزيستور عادي، مش فارقه مكانها. Okay, great. Guys, I'm just going to take a short break عشان I need a drink. ومش الدرينك اللي انتم متخيلينه, so just a regular drink. So we're taking a short break. I'll just get some water and I'll يلا نبص quick question. لا انا اميتر مش هيقرا 10 امبير. بليز خدي بالك الاميتر ما بيقراش الفولتج، الاميتر بيقرا الكرنت. ammeter بيmeasure current. So in this case هيقرا 0.5 ampere. يعني the ammeter here, let me just mark that. The ammeter here is going to measure 0.5 ampere because that current. The ammeter over here will also measure 0.5 ampere. اللي هيحصل ان الفولتميتر هنا هيقرا 5 volts because ده خد 5. And if I had connected the voltmeter here هيقرا 5 volts. So please don't confuse voltage, الحاجة اللي احنا بنعمل لها delivery هنا، وcurrent اللي هي الامبير اللي هي السرعة بتاعت الcharges. So the ammeter just measures how fast the charges are moving in the wire. Okay. لو حاطط voltmeter بعد ال two resistors, do you mean like this? ثانية واحدة. Like, do I put it over here مثلا? Because if you connect a voltmeter على wire فاضية, this will just give you 0 volts because there's nothing to measure. But if you connect the voltmeter here, it will still measure 5 volts. ده هيmeasure 5 وده هيmeasure 5. If you connect the voltmeter على الباتري هيقرا 10 volts. Okay. If there's an increase in diameter هيفرق عن area عامة. Yes هيفرق عن area شوية, but think of it the same way. لو diameter زاد يبقى الاريا زادت, ولو الاريا زادت resistance هتقل. But keep that specific math to when we solve problems next week. Okay, you're welcome. Let's continue so we can finish this up. Next up, parallel connections. What do we mean by parallel بقى? That you put them as shown. بس what do I mean by parallel تاني? And there's a junction in the wire and each component is placed on a separate part of the wire. Each component is placed on a separate part of the wire. So if I were to connect this to a circuit, like let's draw the rest of the circuit. كده مثلا, let's put a small cell over here, and let's say this is a 10 volt cell, and here's the current. Let's call this I. The current اللي اسمها I اللي جاية دي وهي ماشية, it'll find itself at a junction, at a splitting of sorts. الوار بيتقسم. Part of the current goes up, part of the current goes down. يعني جزء من charges بيطلع, جزء من charges بينزل, which causes the current to split. طبعا the current goes back here and joins together and continues. But that's the first difference between a parallel and series connection. In series, there's only one way the charges can move. طريق واحد, سباق. Just think of it like a track, a ring كده بتجري عليه. However, when it comes to parallel connections, انت ماشي, sometimes the charges go up, and sometimes as the charges move, they sometimes go down, or maybe they just split up فوق وتحت فيمشوا فوق وتحت, and then they go back to the battery and so on. Okay? Next بقى. The total resistance in parallel, الtotal resistance في البارallel بيقل. يعني resistance بتقل because when you connect components in parallel, what you're actually doing is you're allowing more charges to go through. كأنك بالظبط جبت wire and you made it bigger. Because when you increase the diameter of a wire or the area of a wire, you allow more charges to go through. فكنا بنقول إن resistance بتقل. Like when we increase the area, this caused more charges to go through. The resistance بتقل. However, when you connect things in parallel, it's the same idea. You gave the charges more paths to go through. بدل ما هو طريق واحد بقوا 2 بقوا 3 بقوا 4. So when the charges move through and they find more spaces to go through, فالcurrent بيزيد. If the current increases, يعني هكتبها بس. If the current increases, التوتال current, خدوا بالكم أنا ما قلتش على التقسيمة, اللي طالع من الباتري, ده معناه إن resistance in the circuit has decreased. It's not resisting زي الأول. أنت بالعكس قلت الcharges تعدي أسرع شوية. That's the first thing. طب بما إن resistance بتقل بنحسبها إزاي؟ With a very easy equation. بنقول 1 over R total equals 1 over R1 plus 1 over R2. You'll notice that this is the exact opposite of the series equation. يعني ده R1 plus R2 دوت 1 over R1 plus 1 over R2. Or this is just a little bit of math, but you could also use product over sum. يعني R1 times R2 على R1 plus R2 if you want to calculate the total resistance. Now finally, ودي مهمة قبل ما نعمل example, كل resistance بياخد full voltage من supply. يعني لو supply 10 volt هيبقى أول resistor ده, let's call this اللي هو بنسميه R1, ده هياخد 10 volts من الباتري. ده برضه هياخد 10 volts من الباتري. The question is why? When you connect things in parallel, بدل ما يطلع one charge from the battery بيطلع 2 charges from the battery. وكل charge من دول بتبقى شايلة معاها 10 volts. Remember, voltage is the amount of energy per charge. فده شايل 10 ده شايل 10. Now when these two charges هما بيتحركوا يوصلوا النقطة دي, they realize that they have to split. ففي واحد بيطلع لفوق لسه شايل 10. Remember, شايل 10 هو ده اللي اسمه voltage. وواحد بينزل لتحت. فاللي اتقسم هنا مش الفولتج, اللي اتقسم هنا مين؟ الكرنت. اللي اتقسم هنا مين؟ الكرنت. الكرنت كان 2 أمبير مثلا, واحد طلع فوق واحد نزل تحت. So as this one goes up, we delivered 10 volts كاملة to the first resistor because there's nothing else in the way. the second اللي نزل لتحت بيوصل ال 10 volts بتاعته برضو كاملة because there's also nothing else in the way. فاللي بيحصل إنه we deliver more charges، يعني نطلع charges أكتر عشان نوصل ال full voltage to each component. كل component بياخد voltage قد بعض. Okay? Good? Good. تعال بقى نجرب example ونحسب. في الإكزامبل بتاعنا إحنا هنقول let's use the same numbers. الباتري 10 volts، الريزستور ده 10 ohms، والريزستور ده 10 ohms. Maybe I should just clean everything up ثانية واحدة. Okay, this is a 10 volt supply. The 10 ohm resistor, that 10 ohm resistor, and number one, what I want to calculate is the total resistance. عايز أحسب ال total resistance. تعال نحسبها بقى. هنقول 1 over R total equals 1 over R1 اللي هي 1 over 10 plus 1 over 10. هيديني 2 divide by 10. If you don't know how to add fractions, just do this on your calculator. That's not your answer because أنا عايز R total. This equation gives you 1 divided by R total. So I'm going to flip the fraction over and R total equals 10 over 2. 10 over 2 ب 5 ohms. فده ال total resistance. واخدين بالكم ال total resistance بقى بكام؟ ب 5. أقل من الاتنين دول. يعني لو ده ب 10 وده ب 10 بقى أقل من 10. Okay, good. That's the first step. حسبنا ال R total. طب second step عايز أحسب ال current. التوتال برضو اللي هو التوتال current اللي جاي قبل ما يتقسم. عشان نحسب التوتال current I still need the same equation I used before اللي هي V equals IR، بس المرة دي هنقول I equals V over R just like this time. I equals V over R. بس which I do I want؟ التوتال يبقى نحط أنهي resistance؟ التوتال. This is important again. We use this rule over and over again. بس which values you use depends on which components we're talking about. So if we're talking about total current يبقى أنا عايز total resistance. عايز R1 يبقى أنا بجيب I1. وهنجربها دلوقتي. ال V اللي هي 10 ليه بقى؟ Because we said in parallel ال voltage مش بتتقسم، فكل حاجة واخدة 10 volts. ده واخد 10، ده واخد 10، ده واخد 10 لو كان في واحد تالت يعني. Over 10 هيطلع لك كام أمبير؟ 1 sorry over 5. My bad, I made a mistake. Remember احنا قلنا عايزين نحسب ال RA ال I total. ال R total بكام؟ لسه جايبينها من شوية ب 5. ف 10 over 5 which is the total هيطلع لي 2 أمبير. زي ما احنا رسمنا من شوية احنا قلنا هيبقى فيه فعلا 2 charges ماشية. Maybe there'll be more. بس في 2 charges ماشية. كل واحدة شايلة 10. The question is بقى ده هيوصل له كام أمبير؟ Like the first resistor هيدخل له كام أمبير؟ I'm guessing 1 أمبير عشان هيتقسم. وذ second resistor هيدخل له كام؟ we need to calculate that برضه. فتعالى نحسب current 1. طبعا لو عرفنا current 1 هنجيب current 2. current 1 ب هنقول V equals IR يبقى I equals V divided by R. So هنقول I1 equals V over R1. ال V ب 10 because it's still the same voltage over R اللي هي كام؟ 10 because أنا بحسب بتاع 1 بس هيطلع لي 1 ampere as I expected. فالcurrent الأولاني ب 1 ampere. Let's write that down. 1 ampere. And the second current is also 1 ampere. Okay? Good. طبعا when they join back together after they deliver the energy it goes back to being 2 ampere. يعني current هنا قبل ما بعد ما طلعت من الباتري وقبل ما تدخل على resistors is 2 ampere. وthe current بعد ما طلعت من 2 resistors is also 2 ampere. Excellent. فده كده في ال parallel. Okay? Remember in parallel the current is divided, the voltage is not. In series, the voltage is divided, the current is not. current ثابت. Finally بقى ايه ال advantages بتاعت ال parallel يعني why is parallel such a good thing يعني why is there an advantage to it? Well easy. طالما احنا حاطين حاجات in parallel each one has its own separate wire and if each one has its own separate wire number one you can attach a switch to each one separately so I can control them independently. Second, if I break one of these components الباقي هيشتغل عادي. يعني if I break the first lamp الباقي هيشتغل because they don't share the same wire. And finally ودي مهمة everything in parallel gets the full voltage from the supply. يعني لو السبلاي هنا اللي أنا رسمه ده 10 volts ده هياخد كام؟ 10 volts يبقى هتنور at maximum brightness. طب اللمبة دي هتاخد كام؟ 10 volts. طب اللمبة دي هتاخد كام؟ 10 volts. طب what if I had a fourth lamp؟ هتاخد كام فولت؟ 10 volts برضو. يعني it doesn't really matter. كل حاجة in parallel بتاخد نفس الإيه؟ الفولتج. So those are the advantages of series in parallel. طب now آخر حتة في السيركتس ونقفل بقى السيركتس كده خالص is a special type of circuit called a potential divider. I wouldn't really call it special because if you take a look it's just two resistors in series. يعني هما 2 resistors in series مش أكتر. It follows the same rules we used before. هي إيه rules that I used before؟ ثانية واحدة my cursor just disappeared. Oh, there we go. إيه rules إحنا قلناها قبل كده؟ If this was 10 volts وده 10 ohms وده 10 ohms إحنا قلنا there is only one current that goes through والvoltage بيتقسم. أنا ههتم قوي بالvoltage هنا. Okay, I'm going to care a lot about voltage here. according to what we just calculated ده هياخد 5 volts وده هياخد إيه؟ 5 volts because they're in series. But if I connect a light bulb in parallel to only one of them مش الاتنين واحدة فيهم اللايت bulb دي مش هتاخد 10 volts هتاخد 5 volts بس because it is only parallel to this part of the circuit not the entire thing. لو كانت اللايت bulb متركبة من الأول للآخر كنت أقول لك 10 volts مفيش مشكلة. But because it's parallel to only one part of the series circuit بتاخد نفس الفولتج اللي إيه قصادها. خلاص we call this a potential إيه divider. يعني خدنا الفولتج البوتنشال difference وقسمناه. ليه؟ عشان ناخد جزء منه. طب دي لازمته إيه؟ Well this actually has a lot of applications. إن لو خليت مثلا واحدة فيهم ثيرمستر أو خليت واحدة LDR or something this allows me to control the brightness أو the voltage using temperature or using light. بس بقول لكم إيه؟ بدل ما نحط fixed resistors أو resistor thermistor و fixed resistor ونقعد نغير في تقسيمة الفولتج كده let's do something else. Let's use a variable resistor. Right now لو ده 10 volts supply I didn't change the colors مش مهم. If this is a 10 volt supply الواير دي كلها let's say إنها 100 ohms يعني كلها على بعض 100 ohms طولها كامل كده. طب واخدة كام فولت؟ 10 فولت because مفيش غيرها في السيركت. But if I connect a slider over here فاكرين sliding contact slider في النص وركبت سلايدر ده بلايت bulb كده اللايت bulb زي الرسمة اللي جنبها مش parallel للسيركت كلها it's only parallel لإيه؟ لنص السيركت. إن لما سلايدر يتحط في النص كأنه قطع الواير لنصين واحدة 50 ohm والتانية 50 إيه؟ ohm which means إن الفولتج I just want to change the color please thank you let me change the color. إن الفولتج اللي على النص التحتاني ده برضو 5 volts والنص اللي فوق ده برضو إيه؟ 5 volts اتقسم equally زي ما احنا رسمنا في الرسمة الشمال. طب تقولي طب إيه الفرق؟ الفرق بقى هنا إن I can change the voltage freely variably by moving the slider up or down. لو حركت السلايدر هنا تحت هياخد 0 volts because it's parallel to nothing. لو حطيت سلايدر فوق خالص هيقرا 10 volts أو هيوصل 10 volts لللامب. So by moving the slider from the bottom to the top gradually أنا أقدر أزود الفولتج بتاعت اللامب gradually. ولو نزلت سلايدر لتحت أقدر أقلل البرايتنس بتاعت اللامب by decreasing the voltage. عشان كده دي اسمها variable potential divider because it's a variable resistor بس كان هدفها إنها تكنترول هنا الفولتج. هدف potential divider إنها تكنترول the voltage أو potential difference زي ما بنقول. Okay? Before I finish up electricity خالص وأقول year 9 يمشوا I'm going to take one final look at the chat كده في السريع. فاضل السيفتي بس. يا جماعة. What's the main difference between series and parallel اللي أنت شفته؟ Main difference number 1 resistance في السيريز بيزيد resistance في البارallel بيقل. Number 2 الكرنت في السيريز مش بيتقسم الكرنت في البارallel بيتقسم. Number 3 الفولتج في السيريز بيتقسم and the voltage in parallel مش بيتقسم it's not split. لو ركبت كومبوننت تاني في السيركت الفولتج هيتقسم ازاي؟ again حسب انت قصدك في انهي circuit because if they're in series الفولتج بيتقسم بس. When can the bulb get burned in a parallel circuit? Look, any bulb or component only gets burned when the current increases way too much. يعني لو أنا وصلت لها voltage أو current higher than what it can handle, it'll burn out. هو إزاي ال R total أقل منهم ب 10؟ That's because البارallel زي ما قلنا بيقلل ال resistance إنه بيزود ال number of charges اللي تقدر تعدي. ماشي يا مالك؟ It just allows more charges to go through. And if it allows more charges to go through ده كأن resistance قلت. ده مش معناها ان التن لوحدها قلت لفوق او التن اللي تحت قلت. It just means together هم خلوا الباتري ايه تطلع current اكتر. مستر يو في الزقازيق؟ لا مستر يو مش في الزقازيق. مستر يو is going to join us very shortly. هي دي حاجات year 9 yes. طالما انا مش حاطط العلامة اللي فوق يبقى دي كلها حاجات ايه year 9. لا year 9 ما خلصوش يا زياد. اوكي excellent. اوكي اخر بقى حاجة ونخلص بقى كده ان شاء الله. طبعا year 10 هيقعدوا معايا سنة زيادة. عايزين نتكلم بس عن electricity في البيت والسيفتي. This is quite simple really. فايش البيت مختلفة شوية عن أي باتري ولا حاجة because if you haven't noticed sometimes they have 3 sockets لما تيجي تحط plug sometimes they have 2 so the sockets are not even marked يعني ما بيبقاش عليها مكتوب positive أو negative. That's because electricity في البيت مش positive or negative ملهاش positive or negative side. Electricity في البيت is known as AC or alternating current. alternating current معناها ان ال value بتاعت ال current ال direction بتاعته بتتغير. لو انا خدت مثلا voltmeter ووصلتها على الفيشة دي just to see ال voltage بيحصل له ايه over time unlike a battery the voltage في الباتري متنسوش انه بيبقى constant ماشي unlike a battery ال voltage بتاع الفيشة دي هيقعد يزيد ويقل بعد كده يبقى نيجاتيف ويزيد ويقلب النيجاتيف ويبقى بوزيتيف ويبقى نيجاتيف ويبقى بوزيتيف. بوزيتيف ونيجاتيف simply معناها ان الدايركشن بتاع current keeps changing. يعني sometimes this is the positive and negative فالcurrent يمشي كده. sometimes this is the positive and negative ده بيرجع كده. We call this an alternating current. ليه alternating؟ هناخده بكرة إن شاء الله لما نيجي نراجع الجنريتور. بس الجنريتور اللي بيجنريت electricity في الباور ستيشنز بيطلع current alternating يعني it keeps changing directions. It's never fixed. Okay. طب if we're not calling them positive or negative يعني if I'm not calling this side positive or negative what do we call them? One of the wires ورا الحيطة بتبقى اسمها the live wire and the other wire في الحيطة برضو is called the neutral wire. The live wire is where all the voltage and current comes in from actually يعني this is the voltage اللي بتبقى حوالي 220 240 volts. This is the voltage at home. It's a very high voltage and this is usually at 0 volts. فلما أنا بحط فيشة هنا like if I take a plug and I plug it into the socket الكرنت بيجيلي من الشارع اللي هو في بيتي يعني through the house from the live wire into the device. Let's say I'm charging my phone or something and then it leaves through the neutral wire. Basically هو ده في السيركتس لما كنا بنرسم دايرتين كده واقول لكم ده السبلاي هو basically دي الفتحة ده السبلاي. فلو انا حطيت الريزيستور او التليفون كده هنا الكرنت بيطلع من اللايف ويروح للنيوترال. we always assume that بس طبعا الدايركشن بيقعد يتغير يعني شوية بيبقى كده شوية بيبقى كده. So at home we do not call them positive and negative we just call them live and neutral and الكهربائية لما بييجوا يركبوا الحاجة دي ما بيبقوش يعني ما يهمهمش يعني ناحية اللايف والنيوترال because كده وكده الكرنت الدايركشن بيتغير. okay. sometimes الفيشة بتبقى فيها فتحة تالتة مش في مصر و there are different countries يعني this is a European plug by the way. في مناطق في يوروب بتبقى الفتحات كده وفي مناطق في يوروب this is in the UK بتبقى فيها 3 فتحات. الفتحة التالتة دي يعني دي بتبقى اللايف لسه برضو ودي بتبقى النيوترال والفتحة التالتة دي بنسميها الإيرث أو الجراوند. forgive my amazing handwriting, and the ground. بس دي هنتكلم عنها بعد سنة صغيرة قوي. فده electricity في البيت. It's 240 volts alternating, so it's very dangerous actually to deal with electricity على طول. يعني لو صباعك لمس الميتال ده على طول كده not a good idea انك تخلي صباعك يلمس الميتال وانت حاطه في فيشة الكهرباء، مش الفوق دي actually اليمين او الشمال, because you don't want to get shocked when you plug it in. So we have 3 safety features to protect either you, مش Mr. You, خدوا بالكم لسه, either you or your devices at home or your house from the current. Because لو current زاد قوي, if the current in any place increases way too much beyond اللي احنا محتاجينه, the devices will burn or it will break down, or not so good things will happen. So the first device that we use is called a fuse. A fuse بتبقى actually a very very thin wire. ساعات بنحط له protective cover زي ده عشان نركبه في circuit, ساعات لأ. بس the thing is, the fuse is a very thin wire that is designed to melt at a specific current. And it's designed to melt at a specific current. فلو احنا قلنا الفيوز ده, let's zoom in. Let's see if I can see what's written over here. Unfortunately مكتوب عليه ولا لأ؟ Actually مكتوب عليه 3A, 3 ampere. فالفيوز ده مكتوب عليه 3 ampere. Maybe you couldn't see it, but كان محفور فيه فوق هنا كلمة 3 ampere. So if this is a 3 ampere fuse, ده معناه ايه؟ ده معناه ان الكرنت اللي جاي لو اقل من 3 ampere, كان 1 ampere, 2 ampere, 0.5 ampere, هيعدي عادي كأن ده واير طبيعي جدا. But لو الكرنت اللي جاي, لو الكرنت اللي داخل الفيوز ده اكبر من 3 ampere, هيسيح الفيوز فمش هيوصل electricity. تيجي تقولي why do I want that? For example, let's say اللامب اللي في السيركت اللي احنا شايفينها دي دلوقتي, اللي راسمين السيركت بتاعتها, دي فتحة اللايف اهي ودي النيوترال. Let's say this lamp can only handle up to 10 ampere. And I decide to close the switch, والcurrent اللي جاي 10 ampere. تقول لي عادي, no problem. أقول لك صح, there is no problem. However, لو الcurrent اللي جاي ده لأي سبب, maybe الكهرباء حصل لها حاجة, maybe حصل electric surge, maybe حد ركب حاجة غلط جنب اللمبة, it doesn't matter. If anything happens in the circuit وخلى الcurrent ده ما يبقاش 10 ampere, خلاه يبقى 12 ampere, أو let's make this worse. Let's say 20 amperes. بس let's say يبقى 20 ampere. So if the current اللي جاي ده بقى 20 ampere, هيعمل ايه؟ لو وصل لللامب هيحرقه او هيخليه يفرقع. not a good idea. فبنروح احنا حاطين قبل اللامب a fuse. يعني over here we've got a fuse. الفيوز ده مكتوب عليه رقم. let's say الرقم بتاعه 11 ampere. خلاص. 11 ampere معناه ايه؟ ان لو current اعلى من 11 it'll burn. فالكرنت اللي جاي ده 20 ampere. الكرنت اللي جاي 20 ampere, جاي هيعدي على السويتش, هيوصل الفيوز. Is it more than 11? Yes, الفيوز هيسيح. ف when the fuse melts بيبريك السيركت وبيمنع الكرنت انه يوصل لللامب. تيجي تقولي بس كده اللامب مش هتشتغل. not a problem, مش مشكلة, اللامب ما تشتغلش, بس المهم ما اتحرقتش. طبعا if the fuse blows as we say, كل اللي بنعمله بنروح فاتحين السويتش, ناخد الفيوز القديم اللي that melted, نرميه ونحط فيوز جديد مكانه بنفس الرقم, and we turn the circuit on, it works just fine. So the purpose of the fuse is to protect your circuit or your components from an overload of current by causing the fuse to melt. نفس الفكرة بقى في حاجة اسمها circuit breaker. في البيت عندنا device اسمه a circuit breaker. circuit breaker هدفه انه protect us or protect الهاوس بتاعي من ال overload of current اللي احنا قلنا عليه من شوية. يعني لو current زاد في البيت عندنا, في الحيطة, في السلك, هيحرق لي الوايرز اللي في الحيطة, and that's not a good idea. We want to limit الكرنت بتاعنا عشان ما نحرقهوش. بس مش هنقعد نحط فيوز في البيت بصراحة. يعني مش هنقعد نحط فيوزز في البيت والكلام ده كله. ليه بقى؟ because it's مش كل مرة فيوز يضرب هيتشيله وتحط الكلام ده كله. That's why جنب باب الشقة, and forgive me, I'm just going to فهدف السيركت بريكر ايه؟ ان لو الكرنت اللي داخل الشقة it's way too high, اعلى من الشقة ممكن تستحمله, it flips the switch. These are all different switches, but all of these switches are actually connected to electromagnets. يعني زي الرسمة اللي فاتت، في لايف وفي switch، وبدل light bulb let's say this is your house. My god, something's wrong with my okay, so again there we go, it's much better now. في switch وفي البيت بتاعك. This resistor just represents your home. This is the live wire and this is the neutral wire. Let's say البيت بتاعك بيستحمل 100 ampere. So لو current وصل ل 100 ampere not too good because ده معناه ان بيتك يتحرق. So what we do is we do the following. نروح حاطين هنا مكان السويتش ده، بنركب فيه، بنخليه an iron switch, we make it out of iron and we close it، يعني بنخليه مقفول كده، ونحط تحتيه أو فوقيه an electromagnet which we sometimes call a coil. الكويل ده بيتوصل باللايف واير no problem. الوايرنج كده مش كامل صح بس مش مشكلة. and this is closed off، محطوط في علبة كده صغيرة and you can only see the switch from the outside، البلاستيك اللي بره. If the current that's coming in to the house from the live wire من street is less than 100 ampere, let's say it's 20 ampere، هيعدي عادي جدا، مش هيقدر يدخل في الكويل because it's designed not to accept غير 100 ampere أو أكتر. هيعدي من السويتش، هيكمل لبيتك، هيشغل بيتك no problem وخلاص because it's safe, it's not a problem. But what if this current is not 20 ampere? What if it's 200 ampere? أعلى من البيت محتاجه كتير. What happens is that this current first passes through the electromagnet. If it's over 100 and it is, electromagnet يشتغل. And because it's a magnet, it attracts the switch. بيattract the switch وينزله لتحت. Meaning it opens the switch. It opens the switch. This is no longer there. So there is no current. There is no current that's going to reach your home. وده اللي بيحصل لما السويتش بيتريجر أو بيفليب. مفيش current بيوصل لبيتك. فبتلاقي الزرار بتاعك اتحرك مكانه. Maybe it goes down, maybe it's up, maybe it's left, maybe it's right. المهم إن اللي بيحصل إن the switches move. The reason they move is because inside there's a small electromagnet that moves the switch or opens the switch when the current gets too high. And that's pretty much it. Oh, the circuit breaker. So the function of the breaker is to cut the current if the current gets too high, okay, by using an magnet. Finally, مش ناقص غير ان احنا نتكلم عن الارث واير او basically مستر يو. مستر يو بقى له شعر اهو، وسعيد جدا انه رجع تاني معانا، بس طبعا طالما طلعنا مستر يو يبقى probably هيحصل فيه حاجة دلوقتي. ايه المشكلة؟ حاجة زي دي. let's say this is an oven or maybe a washing machine. These things usually have a case made out of metal. تقول لي no problem mister, made out of metal. The problem is the following. يعني focus بقى كده. اللايف واير اللي جاي في الفيشة دي it's usually connected to lots of different parts inside the washing machine. بس لو اللايف واير غصب عنها اتقطعت جوه الماشين not our fault جوه الماشين ولمست الميتال كيس، اللي هيحصل ان الكرنت هيمشي through the metal case وجوه مستر يو. We forgot to label Mr. U. He's very happy right now. So when the current goes through Mr. U ويوصل through him and passes through him، اللي هيحصل he will light up. هيبقى مستر، مش عارف نسميه ايه دلوقتي، مش عارف اقلش بصراحة اسميه ايه دلوقتي، بس يلا مستر يو 2 او مستر يو منور. I'm pretty sure one of you will come up with a better joke than I will. بس يلا. So Mr. U is going to get slightly shocked. حلو. No, not really. مش مستر يو حلو لينا عشان احنا فاهمين اللي هيحصل، بس مستر يو كده ممكن يروح فيها. So what do we do to protect Mr. U? طبعا أنا عارف إن أنتوا بتحبوه جدا، ف we need to protect him by using that earth wire. فاكرين الوصلة التالتة اللي إحنا رسمناها من شوية اللي هي راحت فين؟ أهي. This one over here. This is connected. This is not really connected to the power supply بتاع الفاكتوري ولا بتاع power stations. This is just connected to a long piece of metal in the building called the earth wire. اللي بيحصل إنه when Mr. U touches that case، بدل ما الكرنت يمشي through the case and into Mr. U، احنا بنجيب واير تالتة، احنا اللي بنجيب واير. Let me change its color so that you can see it. Let's make it orange. احنا بنجيب واير نوصلها بالearth، يعني بنطلعها بره ونوصلها بالearth. So when the current goes in through the live wire into the case, بدل ما يمشي جوه مستر يو it instead goes from the case out into the earth wire تاني. فهدف earth wire إنها تاخد current from the metal case and transfers it outside بدل ما يوصل لمستر يو. So Mr. U does not get shocked and he's still dull as he is and nothing else happens to him, and we have now saved his life. He should be very happy that he does not get shocked. فتاني, what's the function of the earth wire? It's usually connected to metal cases and it takes the current away from the metal case into the earth wire to protect you, Mr. U قصدنا يعني, from an electric shock. ودي ال safety features كلها. Okay? كويس أوي. هاجر ال AC و DC are just two different types of current. DC معناها إن الكرنت بيمشي من positive ل negative بس, that's all. إنه له direction ثابت. AC means ال direction بيقعد يتغير. ال positive وال negative بيقعدوا يتغيروا. بس. هو ال overload of current بيحصل من إيه؟ بيحصل يا عمر sometimes من إن الكهرباء من محطة الكهرباء نفسها بتزيد فجأة. Sometimes لما الكهرباء بتقطع وترجع تاني the voltage just suddenly spikes ويرجع تاني. Sometimes اللمبة نفسها أو component نفسه مع الوقت بيبوظ so its resistance decreases فالكرنت اللي جواه بيزيد. يعني there are many different things that could happen. Okay. Is AC or DC safer? There's no such thing as safer because if the current, even if it's DC and the current is super high, you'll still, perish. If it's AC and the current is super low, مش هتحس بحاجة. Maybe a little bit of tingling. فمش فارقة. هو في البارلل كل ما بتزود resistance the current هيزيد. Yes, كل ما تزود resistance in parallel the total resistance بتقل فالcurrent بيزيد. Okay, anything else? I don't understand the part of variable potential divider. I'll try to go over it again here, Jojo, but otherwise just go back and rewatch it during the replay. And Hannah, why is it never fixed? Why is what never fixed? Please be clear, please. Thank you. Why is the earth wire not available in all countries as safety? Because this is less political بصراحة and more when you build a building like your house or your villa or something. لازم نبيلد الديزاين بتاع البيت ونعمل حسابنا الكهرباء ماشيه ازاي ولازم الكونتري تتفق مع الناس اللي بتمانيفاكتشر الفيش والالكتريكال ابلاينسز لازم شكل الفيشه بيبقى عامل ازاي. So a long time ago before ما اخترعوا حوار الارث واير دي دول كتيرة قوي كانت شغالة عادي باللايف ونيوترال. When they introduced that earth wire it was very expensive especially لو احنا وزعنا الانفراستراكشر على بلد كبيرة مرة واحدة. يعني it's very expensive to go back to all of the older buildings and change الكونكشنز كلها عشان يبقى فيها 3 فتحات بدل 2 وانك تخلي المانيفاكتشرز كلهم يغيروا الفيش اللي بيصنعوها ل3 أو 2. طب what if وحد في بيته ما عندوش ال3 مش هتدخل عنده الفيش ففي مشكلة بس مش أكتر يعني. Anyway, that's why it's not available in all countries يعني. Plus it's usually available in factories and labs. The parts where the places where it's important خلاص it's already been dealt with. Okay, year 9s. Thank you very much for attending. يا ريت تاخدوا بعضكم بقى وتمشوا. If you'd like to leave now. خلاص. Year 10s. اقعدوا معايا شوية. I only need about 5 to 10 minutes معاكم بكتير قوي and we'll be done as well. Okay? يلا. Year 10s بقى. We have 2 or 3 things to talk about. واحد هنتكلم عن component اسمه diode. الدايود ده عبارة عن component allow the current to only flow in one direction. إنه بيستخدموه عشان نحول من AC ل DC. هنتكلم عن حاجة اسمها ال IV graphs as in how do we draw IV graphs. وهنتكلم عن حاجة اسمها logic gates وإيه هدف logic gates and what are different types of gates that we have. هما دول الثلاثة بس اللي عايزين نبص عليهم دلوقتي. So, what's a diode? A diode is a special component that only allows the current to flow in only one direction. هو ال direction بتاع الارrow. خلاص if the current tries to flow in any other direction يعني جاي بالعكس كده it will not flow أصلا والcurrent هيقف. So as a quick example, if I were to draw a circuit بsupply وادي diode وادي light bulb وقلت لك إن this side is positive and this side is negative, will the light bulb light up? And you would say yes. Yeah. Why? Because the current is flowing from positive to negative and it flows this way and it'll reach the battery عادي جدا, and if the current is moving in the direction of the arrow of the diode هيعدي عادي. However لو أنا عكست البولز بتاعت الباتري, يعني ده مش positive and this is not negative. If this side is positive and this side is negative, the current wants to flow from positive to negative, يعني ناحية الشمال, but if it moves this way هتيجي عكس الدايركشن بتاع الدايود, so the diode stops it from moving أصلا in the first place. طالما في diode عكس الدايركشن بتاع current in reverse يعني, it does not let the current go through, so the light bulb does not light up. تاني, its charges will not even move if the diode is in the circuit, anywhere in the circuit بالعكس, so it doesn't allow the current to go through. طيب, the main function of the diode is to convert AC to DC. AC زي ما اتفقنا اللي هو alternating current, اللي هو الفولتج اللي مش ثابت, بيبقى شوية positive وشوية negative, بيجي من ال generators. So if you forgot about that, please make sure to review it, but we'll review that tomorrow برضه إن شاء الله. أما ال DC اللي هي جاية من ال batteries, it has a fixed direction, it's always a positive بس مثلا, يعني the current always flows in a single direction. But sometimes حاجة زي الشاحن بتاع الموبايل, like my phone, when I put my phone's charger into the socket, I kind of want to change ال AC voltage بتاع فيشة الكهرباء into DC, because my iPhone, look, this is a beautiful iPhone اهو, this iPhone needs DC to work. So oops, كنت المفروض اكتب AC هنا. So the purpose is to convert AC into DC. Now how does that work? We have two ways. Either if you connect this AC supply to a single diode, well, let's say this resistor represents your phone, ووصلت voltmeter هنا, اللي هيحصل إن ال AC voltage that you put in here will not reach the battery or the phone completely. اللي هيحصل إن the diode will allow the current to flow in one direction, اللي هو الناحية دي, let's call this positive. But if the current wants to go in the opposite direction, or negative, it does not go through. So essentially it passes one part of the current or voltage, but not the other. هتيجي فترة تقطعها, بعد كده تعدي, بعد كده تقطع, تعدي, and so on. So a single diode allows you to stop the current from moving in the opposite direction. It doesn't make it flow in the opposite direction, just stops it. So now you have kind of a DC current, but I don't like this. So we have another design, and the second design that I'm going to draw should not be memorized, okay? You're not going to memorize this design, but this design makes use of 4 diodes. We call this a bridge or a rectifier. We get 4 diodes. We connect them in the shape of a diamond كده شوية. And we connect this side and this side to the top and the bottom بال AC supply. And we connect the left and right sides to the resistor. Do not memorize this, please. How do I memorize? You don't. We just want to take a look at the current, the direction of the flow of the current. Okay. So if I were to draw how the current flows through, we would do the following. First, لو ده كان positive والتاني negative, the current would flow this way. هينزل. Just follow through with the A arrows. How you go through here, it'll meet a junction. It'll move to the right because the left side is blocked, so it moves to the right. وصل هنا. It can't go up top, يعني ما ينفعش يطلع because this is closed, so there's only one way to go, and that is this way. And it reaches the resistor. فعدى. This voltage goes through. Okay? However, if we reverse the direction of the current, if this becomes positive and this is negative, the current flows from positive to negative الناحية دي, and now it is at another junction. It can either move, control, left. It can't move left because this is blocked, so it has to move a right. So it moves this way. وصل لجunction تاني. It can either move left, nope, it can't, so it has to move a right. So it moves to the right بالشكل ده. And it goes through the resistor تاني. بس unlike before لما كان عايز يروح ويجي, يعني it wants to go in both directions, ده ما بيحصلش. It moves in the same direction. So basically what you did was you converted كل ال voltage from AC to DC, بقى كله positive. بس. فتاني, what is this particular circuit called? This is called the rectifier. Because it converts the AC to DC completely. You only need to understand, if it's drawn in front of you, ازاي ال current بيمشي. You don't have to memorize the design ولا أي حاجة. You only need to understand how does the current flow through the circuit. Okay? بس. Yusuf, what if it's precisely 3 ampere in the wire and the fuse is 3 ampere? It'll burn. Okay? إذا كويس, nothing else? I cry. Don't cry. خلاص, we're almost done. إيه ده, what the heck? Why did this transfer over to... Okay, or it didn't. بص, حتى PowerPoint is like crying هو كمان. PowerPoint wants to cry. Mr. U is probably crying. And Mr. U is probably here in the corner, just like lying down, just hands on his face. Tears are dropping. He wants to go to bed, dreaming of, sleep. Aren't we all dreaming of sleep? بس يلا بقى. Anyway, what's an IV graph? This is a very simple thing. If I take something like a resistor and I connect it to a battery, but not just any battery, a battery that is variable, I can change the value of, and then I connect an ammeter, and then I connect a voltmeter. مش كده أنا ممكن أقعد أزود الفولتج وأقعد أقيس الفولتج والكرنت بيحصل له إيه؟ That's exactly what we get if we do that. If I get a resistor and I connect it to a voltmeter and ammeter and I get a variable voltage supply, like a DC battery that I can change the voltage of. If I keep increasing the voltage, the current will increase, and that's what we see here. كل ما ال voltage بتزيد, the current بتزيد. كل ما ال voltage بتزيد, the current بتزيد. كل ما ال voltage بتزيد, the current بتزيد. And that's normal, and that's what an IV graph is. It just shows you ال voltage والcurrent بيتغيروا ازاي. تيجي تقولي طب لازمتها ايه؟ Well, there is a reason we draw it sometimes. This straight line represents that the resistance of the wire is constant. Because when the voltage increased, the current increased proportionally. ما تنسوش إن V equals a IR, أو بمعنى التاني R equals V over I. فلو ال R constant, لو ال V زادت ال I هتزيد بشكل constant برضو, يعني هيطلع straight line. However, لو بصينا على اللامب, يعني if I remove الريزستور من الكونكشن دي وركبت مكانها light bulb instead, a filament lamp يعني light bulb, اللي هيحصل لما بنزود الفولتج الكرنت بتزيد. نزود الفولتج الكرنت بتزيد. نزود الفولتج الكرنت بتزيد. هي زادت بس مش زي الأول, يعني it's not increasing كده, لأ, it has decreased a bit. وده لسبب واحد, because as the current in a lamp increases, its temperature increases, because a filament lamp works by emitting light and heat. بس كل ما ماشي فيه current أكتر بتسخن أكتر, ولو التمبرتشر زاد الريزيستنس بتاعتها بتزيد. طب ده بيبان ازاي؟ إن لما حب أزود الفولتج تاني الكرنت هيزيد بس شوية صغيرين مش كتير, يعني بدل ما الكرنت يقل جامد هيزيد بس بأقل شوية. So the only reason this line is curved بالمنظر اللي احنا شايفينه ده, the only reason this line is curved is because over here the temperature has now increased. ولو temperature زاد resistance هتزيد, لو resistance زادت current هيحاول ايه يقل. وبس هي دي ال IV graphs. يعني if we see them it just shows you in here the resistance is constant because it's a straight line, whereas here the resistance is not constant because it curves. ايه اللي بيحصل resistance بتزيد ليه؟ عشان temperature زادت. okay. طيب. finally هنتكلم عن logic gates. A logic gate is simply a component. A logic gate is nothing more than a component that accepts specific inputs from what we call transducers. Now these inputs could be from a thermistor, an LDR, a switch, a timer, a temperature sensor, يعني different types of sensors. And the output of the gate could be anything like a light bulb, an alarm, a door, some kind of mechanism. In other words, a gate, a logic gate, is the component that's responsible for the processing, the automatic processing اللي الautomatic systems بتشتغل بيها. يعني لما بيبقى عندك السخان الكهرباء اللي عندك بيسخن المية, how does it know when to stop heating the water electrically? Because it measures the temperatures and checks it. If it reaches a certain temperature, it turns your heater off. If it's not at that temperature, it turns the heater on. Maybe you even have it set to a timer. يعني عندك حاجات كتير. So anything that works with automatic control uses a logic gate, and logic gates accept certain inputs and gives you certain outputs. يعني بيشغلك أو يطفي لك الحاجة. Now, logic gates are known as digital components. Logic gates are known as digital components, meaning they work with either high or low currents. يعني يا high يا low. High meaning في current أو بنقول 1. Low يعني مفيش current أو بنقول 0. So maybe you put in a couple of high signals ويطلع لك a high signal or a low signal. الهدف إن لو temperature عالية هيديك 1, لو temperature قليلة هيديك 0, لو اللايت عالي هيديك 1 and so on. واللايت bulbs يا إما هتنور يا إما هتطفي. There is no in between. Okay. Also we have 5 different gates. They're all quite simple. في حاجة اسمها AND gate, OR gate, NOT gate, a NAND gate which is basically an AND gate وراها NOT زي ما هنشوف, و a NOR gate which is an OR gate وراها NOT. بس تعال نشوف دول بيعملوا طيب. First things first, الناحية اللي على الشمال دي بتاعت أي gate, these are the inputs. الناحية اليمين دي output. الانبوت بتبقى current والاوتبوت برضه بيبقى current. اوكي. لو الانبوت هنا 0 معناه مفيش current, و0 هيطلع لي هنا 0, يعني مش هيشغل حاجة. امتى هيشتغل؟ يعني امتى يشغل لي؟ لو ده 1 وده 0 هيطلع لي برضه 0. لو اللي فوق 1 واللي تحت 1 يعني دخلت current في الاتنين inputs, because خدوا بالكم في اتنين inputs, هيطلع لي ده 1 instead. عشان كده اسمه AND. هو بيديني an output, a high output, a 1 لو input 1 and input 2 are high. طب بدل ما نقعد نحكي القصة دي بنرسم حاجة اسمها truth table, which is just all the possible combinations اللي ممكن تظهر للكومبوننت زي ده. فلو قلت 0 0 معناها هيطلع 0, مش يعني إذا دخلت 2 زيروهات هيطلع لي ولا حاجة. 1 و 0 برضه هيطلع 0 because هو مش عايز يطلع لي غير لو هي 1 و 1. 0 1 يعني خليت اللي تحت ب 1 واللي فوق ب 0, فدي 0. 1 and 1 means they're both a high input, يبقى the output is also high, so it turns on. خلاص؟ بس. Maybe that output بقى is a light bulb, maybe that output is an alarm, I don't care. بس المهم if both inputs are high, the output is high. Now, with that logic, I think you can understand the OR gate على طول. An OR gate also has 2 inputs, and it gives you a high output if input 1, اللي هي أول واحد ده, is 1, or if input 2 is 1, يعني لازم ده يبقى 1 أو ده يبقى 1. يعني just to clarify, خليني أمسح بس الشخبطة دي. If input 1 is 0 و 0 هيطلع لي ولا حاجة. If it's 1 و 0 هيطلع لي 1 يعني هيشتغل. لو 1 و 0 بدلتهم هيطلع لي 1. طب لو 1 و 1 هيطلع لي برضه 1. يعني الأور جيت بيشغل لك الكومبوننت if both input 1 and input 2 are high. فده هيبقى 0، 1 و 0 يبقى 1، 1 و 0 يبقى 1، 1 و 1 يبقى ايه؟ 1. اوكي؟ النوت جيت هو الوحيد اللي honestly مش مستاهل truth table because it doesn't have a second input. There is only one input. النوت جيت له اسم تاني اسمه الانفرتر. And the purpose of the inverter is to invert الكرنت، يعكس الكرنت. لو هو داخل له 0 هيطلع لك 1، يعني لو هو داخل 0 هيطلع 1، ولو هو داخل له 1 هيطلع ايه؟ 0. يعني هو كل اللي بيعمله بيعكس الكرنت اللي داخله. لو في كرنت ما بيطلعش، لو ما فيش كرنت هو بيطلع كرنت من عنده. اوكي؟ ف it doesn't really have any conditions other than انه بيعكس. الناند جيت is just an AND gate اللي احنا خدناه هنا وحطينا وراه نوت، يعني خدنا الاند وعكسناه. ففي الاند ال 0 0 كان بيديني 0، في الناند ال 0 0 يديني 1 انه بيعكسها، النوت بيعكسها. ال 1 وال 0 كان بيديني 0 يديني 1، ال 0 1 كان بيديني 0 يديني 1، 1 and 1 used to give me 1 يديني 0. يعني it just takes the output of an AND gate and it reverses it, it inverts it. The NOR gate is the same idea. It's an OR gate followed by a NOT. So it takes the output of the OR gate and it reverses it. So 0 and 0 used to give me 0. So now it's 1. A 1 and 0 used to give me 1. It inverts it. So now it's 0. 0 and 0. So it just takes the OR gate and reverses it. And personally, and this is my own personal preference, I don't even try to memorize an AND or the NOR. I like just memorizing AND, OR, and NOT because they're very logical. And if I want to remember the NAND gate, remember it's just the AND بس اعكسها. Just reverse the output of the AND gate. If you want the NOR gate, just take your OR gate and reverse it. It's just the opposite of the NOR gate. And finally, عشان بس نحل example يبقى كده عملنا اللي علينا وخلصنا كل حاجة. And hope you're thank you for your patience يعني في الحتة دي. Let's say I have an AND gate here and I follow it with a NOT. I could just put a NAND gate, but I just want to do something here. Let's connect this to another gate, which is an OR gate, and let's connect this with another NOT gate لوحده كده في الهواء. So here's a bunch of gates, and I want to find out the output here. Let's call this X. And I'm going to give you a bunch of inputs, and we want to find out what the output is going to be. So let's say this is 0, and this is 0, and this is 1. Okay, so 0 and 0 on the AND gate gives me a 0. يعني هيطلع 0. 0 على NOT gate would change to a 1 because, you know, a NOT gate reverses the current. فال1 دي ماشية هتوصل هنا 1. So let's write 1 over here. The 1 on this NOT gate gets reversed, so now it's 0. And then it moves through, and it reaches this spot, so it's still 0. 0 and 1 on an OR gate, so it's 1 or 0, so it's 1. Using 1, which means X is actually 1. Which means whatever you put here is going to turn on. If it's an amp or an alarm or anything, it's going to turn on. Whew, well, that was exhausting. We took a bit more time than I expected, but that's okay. Quick question. Just a quick look at the questions. Let's see, do we have any? Okay, no more questions? Great. Now, thank you guys for listening. To the last few people who are barely holding on, you lasted this long. Thank you for listening to the entire thing. Mr. Yu did get shocked once, and that's okay with us, but we did save him in the end. It was a great lesson today, بصراحة الحمد لله. Longer than I expected. I'm a bit dehydrated, but that's what you do, you teach. I hope you guys enjoy yourselves, and I hope you have a great day.